So this is going to be the first part of the tutorial of creating like an end-to-end machine learning project. In this project we are going to look at as to how we are going to be utilizing Streamlit. We will be using Fast API for the backend. We will be using databases in this project, and we will also be creating an ETL pipeline. So um, let's start. So the first thing that we're going to do, or the most simplest thing, is that we are going to create the front end or the application. Okay. So in the first tutorial, or in the first step, we are going to assume some of the things. What are we going to assume? We are going to assume, so this is our assumption, that we will be given a machine learning model, and based on the machine learning model we have to create its front end. Okay, which will be created on Streamlit. So this is the assumption, and we're going to be moving with this assumption. So what is going to be the data set, or how is the data set going to look like? What is going to be the machine model? We are using the iris dataset. So we are going to create our entire front end based on the iris dataset. So I will call this as my front end.py file. Over here, we are going to define our main, which is going to be if underscore name underscore equals to underscore scroll main underscore scroll print hello world. Okay, so very simple script. Let me quickly go to this project. So first of all, I'm going to activate a virtual environment which I have already created, because it involves all of the installations that you require. But if you don't know as to how you can create a virtual environment, I would recommend you to use Conda, because it's more flexible and easy. So you would write Conda create -n the name of your environment, and then specify your Python version. I'm using 3.10 in this case. So you will do that. You will create your Conda environment, and then you can activate it. So my project is in my D folder. So we are over here in this folder now, and we have our frontend py file. So I'm going to run my frontend.py file, and it is working. All right. So the first thing that we're going to do is we're going to be importing Streamlit as st, and over here we will write st dot write hello world. We're going to save this. We're going to go back, and we're going to write Streamlit run frontend.py, and this basically is working because it opened up a Streamlit application with localhost 8501, and it is working perfect. So our code is now working. Now we are going to design our front end. So first of all, I want to have a title, and in this title we are going to call this as the iris classification. We're going to remove this because we don't need this anymore. In the iris dataset, there are 4 columns that you require. You need the sepal length, the sepal width, the petal length, and the petal width. So we're going to define all of these 4 variables. So sepal width, petal length, and petal width. Okay, so we are going to be using an input. um, we're going to be using an input st dot. Okay, so whenever you are confused as to which element that you want to use in your Streamlit application, you can always go to the Streamlit uh, documentation. You can go over here and you can look um, at their UI. So let me write Streamlit UI components, and you can look as to which component you want to add. In my case, I want to add an input over here. So let me search for input. Okay, I can't find input for some reason. Okay, check our docs. No, not the docs. So let's go to all. Okay, input still not here. I think this was not the website. Okay, so it's this. Okay, 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 okay. Well, how about gallery? No. In the documentation, maybe fundamentals, basic concepts. Uh, where are its create an app? Hmm. I think they've updated it because components, create a component, custom components, app gallery, API references. Nope, it's not here. Not here. Nope. Okay, here we go. So we had to go to API reference, and over here, if you write for input, yes, here we go. So what we want is a number input. We want this thing. We want a number input over here. So this is what we want. So we are going to add this to our front end. So we're going to write number input, and we're going to write enter sepal length in centimeter. We want we want our minimum value. So let me see if it has the minimum maximum. So minimum value. So the minimum value is going to be 0, 0.0. We want it to be a floating value, and the maximum value to be about 10.0, because this is the minimum and the maximum values that our data set is trained on. And we would also require this to be value equals to 0.0. This will ensure that you will have floating values to be accepted. If you don't add this, then it will be only accepting the integer values, which we don't want. So we're going to repeat this. I can just copy this and then paste this here, and we can call this as as sepal width. And then over here we can grab this again, paste this here, and we can write this as petal length, and then repeat this for here and write this as petal width. Okay, so based on okay, so let's see if this is working. Let's go here and back to our Streamlit application. We're going to run this, and now you can see the values are being updated. So 1, 2, 3, 4, it's working. All right, now we need a way as to how we can somehow um, submit our values to our machine learning model. So what's happening right now is we are going to be creating our front-end application, which is basically going to the user is going to input some user values. So user input values, which are going to be used as inference, and these values are going to be given to our machine learning model. So this is what we're trying to create. So now we need a way as to how we can somehow submit these values. So we need to create a button. So to create a button, we can go back here and we can search for button, and we can go here and you can set you have this code over here. So we can go back over here and we can write submit, or space this. Let's call this as submit. Now, we can save this and then we can run this again, and you will see that now we will have a submit button, but right now this does nothing. So what we want to do is is that whenever we are clicking on this button, which means that whenever this button is going to be clicked on, we want to perform a function. Okay, so the function that we want to perform is going to be, so instead of this, let's clean this up a little bit. Let's define a main function and put this entire code over here, and over here we can just define main, so it's going to be more clean. Now we're going to define a function which we are going to call as predict flower. Okay, so when this button is pressed, we want to call predict flower, which will get four values, which will have our sepal length, our sepal width, petal length, and petal width. And over here we can just copy this, paste this here, and we can now do st.write sepal length, which is going to be our sepal length, and then copy this, paste this four times, and then paste these values, and then let's call this as sepal width, sepal width, petal length, and petal width, petal width. There we go. Now if we go back here, we will run this, nothing happens, but as soon as I hit submit, we get our values. As soon as I change the values a little bit and then we run this again, we get that our values are in fact being changed over here. So this is working now. All right, so our front end UI has been created, but we now want to integrate our machine learning model. So over here, you can see that I've made two machine learning models. So my iris data set was trained on XGBoost machine learning model. Um, how did we train the model? How did we get the data set? All of that part will be discussed in the later videos. Right now, we are going to go with the assumption that you have trained the model, you have the model, and based on that, you're trying to create your front end. Okay. Um, I'll see if I can upload a GitHub link where I will be sharing all of this code so that you can just download the job lib and pickle files from over there, and you don't have to train your model on your own if you're just following along. Okay, so let's move on. Now, our machine learning model has been trained on either joblib or on pickle file. So I will be teaching you as to how you can use both pickle file or joblib as inferences. So for the first model, we are going to be importing uh, joblib library. So to import the joblib library, we are going to write from joblib import. We are going to be just loading the model, and for pickle file we're just going to say pickle. Since our machine learning model requires like a numpy object, so for that we are going to be importing numpy as np as well. All right, and we do not have joblib over here imported, so we also need to import joblib as well. Okay, so now let's try to write the code for predicting the flower. Um, and before I send or before I write the code for predicting the flower, I want to do one thing, and I want to make this a bit more clean. So the way as to how I'm going to clean this is I'm going to say data underscore inference equals to np dot array, and inside here we're just going to cut this and paste this over here. So the reason as to why I'm doing this is because your machine learning model, your XGBoost model requires an NP array, and it's trained on NP array. So that's the reason why before I'm sending the data to this to this function, I am encapsulating that into an MP array. So I'm going to paste this over here, and now we can just call this as data. Now we are going to write the code for using our machine learning model. So to use our machine learning model, first of all, we need to define where our pickle file is at. So we are going to say this as pickle file path, which will be in this folder, and it is going to be called, or its name of the file is xgb underscore model dot pickle. And to use this model, we first want to open the pickle file. So with open pickle file path as, or sorry, not as, rb file, and we're going to call this as f, and then we are going to say that pickle model pickle model is basically, it's basically loading this. So pickle dot load, and then we are going to set our f over here. So our model has now been loaded over here, and now at the end what we're going to do is we're going to write pickle, or predict pickle is going to be your pickle model dot predict, and over here we are going to be sending our data inference. Now the thing is that the machine learning model on which your XGB model was being trained on was trained on a data frame, and the data frame has a lot of rows. So what I'm trying to say is that when we were training the model, we had different sets of, so we had like different rows. So we had row 1, row 2, row 3, row 4, row 5, and so on and so forth. So the machine learning model expects you to have a two-dimensional NP array. But in our case, if you look over here, we are sending as a one-dimensional NP array. So to fix this problem, what we're going to do is we're just going to get the zeroth answer from over here. So with that, you will get the first prediction. So this will be data, and we're going to save this. And as a result, if you want to see our result, we're going to write our answer. So we're going to save this, and we're going to hit back to our Streamlit application. We're going to rerun. We're going to submit and see if everything's working fine. Okay, we got an error, which is that, okay, so we're getting the same error as I was talking about. Okay, so let's take a look as to where I went wrong. So pickle model.predict, I send in the data frame. Yes, so like I said, it should have been a two-dimensional. So it should have been this. Let's save this, and let's rerun, and let's submit now, and we got our prediction. If I don't write this, and if I rerun this, and if I submit, you'll still get your value. But since we want the first prediction, that's the reason why I was writing this as 0. So if you have like multiple rows, so for example, I can do something like, see if this works, something like this. Let's set this value to +1, +1, +1, and +1. And now if I rerun this and submit, I will only get the first prediction because this is 0. But now if I rerun this and submit this, I'll get 2 values. So this is for the first prediction, which was on these values, and then this is the second prediction, which was on these values. So to keep things simple, we're just going to stick with one prediction for now. Now we can do the same thing with joblib as well, and you will see as to how quicker it is to use joblib as compared to pickle. So the first thing that we're going to do is we're going to define our joblib file path. So this is going to be this thing. Then instead of opening over here, we can just write load equals to joblib. Um, sorry, we will write our joblib model is just going to be what? It's going to be load what? The joblib file path. So as you can see, if you compare this code with this code, this one is more clean and it's more easier to use and it's more faster. So this is the reason why as to why I was teaching you to use joblib. So similarly as the predict file, we're also going to write predict joblib, and we're going to write joblib model dot predict on the data of 0. We're going to save this, and we are going to then write st.write predict joblib. So now if we go back to our Streamlit application, we rerun this, we submit, and we get the same answer. All right. So basically, this was me teaching you as to how you can use both joblib and pickle files if you want to use them. And the next thing that we're going to do is we want some sort of physical feedback. I just don't want to print these two and two values. I actually want to see what flower I was predicting. So over here, I have different images. So this is for the first flower, the second flower, and the third flower. And now we're going to write a function which is going to display this image. So to do that, we are going to write define display flower, and this will be taking your whatever prediction that we got from over here, and inside here we are just going to say that the file path to our image is going to be inside the images folder. And which file do we want? We want the file based on the prediction that we got .jpg. And then what we want to do is we just want to print or show this image, so we can show that using st.image and then send our file path. So now instead of printing this, we are now going to replace this by writing display flower for our predict flower, and I can write this as st.write prediction from pickle model, and then we can copy this and I can paste this here, and I can write prediction from joblib model, and we're just going to set our models as our pickle files. We're going to rerun this, and we're now going to submit. We got an error, which is error opening. So I think I don't need to add this. Let's rerun this, and as a result, we got our prediction is just these two flowers. You can add a series of if conditions, which is that if it is 0, then it would be, I think, Iris Setosa, maybe. I'll have to check. If it's 3, I think it's versicolor. So you can add all sorts of um, additional elements to your component, to your UI, and make it as beautiful as you want. But this was all related as to how you can simply just add your models, create a very simple UI using Streamlit, and then predicting or doing inference. So that was all for the first video.